We're going to look at some graphs of radical functions today. So we're going to start with some square root functions. If I'm going to graph a square root, it would be nice if I picked x values to plug in that were perfect squares. That way, when I get my y value, my square root, it comes out a nice whole number instead of like if you do 2, you get like 1.41, blah, 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 blah. So I'm going to use 0, 1, 4, 9, the first 4 perfect squares. And then my square roots of them are 0, 1, 2, and 3. So my graph of square root of x, my parent function, just looks like that. So you can plug in a value less than 0, because if you think about square root of like -1 is I, a non-real complex number. So like we talked about when we were looking at a domain without a graph, the smallest x value we can plug in here and still get real numbers is 0. Our domain of our graph matches that and is 0 to infinity. Our range also, since my square roots are growing in the positive direction, is from 0 to infinity. Now, if we look at one that has some transformations on it, like shifted around, left, right, up, down, I'm going to use my parent function and go from there. So first, let me list out my transformations on this one. So that x plus 2 means I'm taking my parent function and translating it left 2. Minus 4 means I'm moving everything down 4. And the 3 being multiplied times my output of my radical means I'm vertically stretching by a factor of 3. So let's get the points that go along with that. So I could pick a bunch of random x values and just plug them in, but it's easier to use my parent points. So let me clean those up a little bit and we will go from there. Okay, so first off, we need to translate everything left 2. So that affects my x values, makes them smaller by 2. So I'm going to subtract 2 from all of my x coordinates. And then my y values remain the same. Now I need to stretch it vertically by a factor of 3 because I do my multiplications before I subtract that 4 that moves it down on the end. So I will take, and since this is a vertical stretch, I'm multiplying my output, my y values that I just got by 3. So let me take my previous table, multiply all those y values by 3. And I'm going to have those new y coordinates. All right, last thing to do is I need to translate all of my points down 4, which means I will need to subtract 4 from my y values. So if I take one more time my previous table and subtract 4 from all my y values to move it down, I'm going to get my final table of values, which I'm going to clean up for you a little bit and graph. And then you'll have your final graph. Looks like that. Looking at our domain and range, if you think about kind of our starting point there, our x values go from -2, including -2, to infinity, and our range is from -4 to infinity. Now I'm going to graph a cube root. So I'm going to pick x values to plug in that will give me nice whole numbers out, kind of like I did with my square roots. So like perfect cubes would be 0, 1, and then 2 cubed would be 8. And also I can do cube roots of negative values and still get real numbers, so I'm going to include those as well. So there are my cube roots of those values, which I'm going to plot on my graph. So I know 8's a little bit off here, but this is going to make a kind of like gradual curving shape. It looks like a straight line in the middle, but it's not. It is curved. So if you compare it to your square roots graph, it continues forever in both directions because it is an odd root. So my domain is going to be -infinity to infinity. And my range, it is expanding upwards and downwards slowly, is going to be -infinity to infinity as well. Here we're going to do a little bit of matching. So I kind of do process of elimination. If you look at this, this is a square root graph, not a cube root graph, because it does not continue forever in both directions. It stops there at 0, 0, so I can eliminate my cube root. Now let's just maybe label a point and try plugging in the x value and see if we get the right y value. So if you try in our first option, 3 times the square root of 1 is 3. That would mean that function should go through the point 1, 3, which this one doesn't. It goes through 1, 2. But if I plug it into C, it does go through 1, 2. And if you wanted to try D for safety, it would go through 1, 1/2, which is not correct.